All right, friends and students. So we are starting a new chapter or no new topic that is called as semiconductor diode. It's a part of electronic circuit, semiconductor diode. So please remember, now we are discussing about active components. From now onwards, we will be discussing more about active components. Okay. So previous videos we have discussed about passive component. Now we will be discussing more about active components. Okay. So first part, that is, we call it as a semiconductor diode. Why we call it a semiconductor diode? Because it is made up of a semiconducting material. Now, what is semiconducting material? Whenever the semiconductor material name comes, the first thing which comes to our mind is silicon. Okay. Silicon is a semiconductor material. Okay. Previously, say about 25 years back, we all used to have another materials also, that is germanium. But nowadays, you will not find any diode or any germanium diodes in the market, because mostly all the diodes, all type of diodes, it is silicon diodes only. Okay. Now, you can see on this slide, there is a P-type material and N-type material. That is, P-type material is given in orange color and N-type material is given in green color. In between, you have a blue color, a violet color region. Okay. So one side, that is P-type material, another side it is N-type material. On the other side also P-type material and N-type material. Now please remember what is P-type material and N-type. Whenever we discuss or we talk about semiconductor material, it is divided into two type of material. One is called as P-type material, another one is called as N-type material. N-type material, the maximum you will have electrons in it. In P-type material, it will be positively charged, or rather we can say it's a holes. Holes will be present. So joining these two material, the part or the product, what we get, it's called as diode. Okay. So diode, you can call it as one side as positive, that is, we call it as anode, and negative side, we call it as a cathode, right? Okay. So two terminals, anode and cathode. On right hand side, you can find these are the symbols. You can draw it like this. How you will come to know which one is cathode? There is a strip mark, or there is a marking on it, a silver color marking or some sort of a marking. It will be there, it will be present, which will represent anode, or which will represent the cathode side. Okay, right. So anode is positive, cathode is negative. That you have to remember. Please remember one important point. Diode work in forward bias only. It will not work on the reverse bias. The details you can see on the top here, it is just given, but I will not discuss about that. So forward bias, it will work. What do you mean by that? That is, when the current is passed, it will allow current only in one direction, only in one direction. That you have to remember. Achha. The minimum voltage on the positive side, that is anode, it should be more than 0.7 volt. Then only the diode will function, or it will conduct, and you will get the output on the cathode side. Okay, right. So next is, we'll come to the next slide. Okay. Working principle of diode, we have discussed how you will work, and we will practically see how to test the diode with the help of a multimeter after this. Okay. Where the electrons fall forward bias and reverse bias, it will not work. Forward bias only it works. Okay. So that, yeah, this it is given in this working principle. We go to the next slide. Now here comes to types of diode. Before going to types of diode, you should remember there are different type of diodes with the different functions, right? What are the functions? Mainly, what are the functions of the diode? There are two main functions of the diode. One is called as the rectification, another one is the regulation, and we call it the third function, we call it as a switching. So rectification and regulation are mostly we study in our colleges or in our core subject, right? Okay. After that, but we should also understand it is used for many other purposes. Like signal modulation, signal mixing, demodulation, oscillation circuits, for emitting diodes, for laser diode purpose. So all these things we have different work. So in this chart, you can see rectifier diode has anode and cathode, right? How does it look? Convert, what is rectification? Converting AC to DC. Light emitting diode, it will only give you light. The arrows will be going out in the symbol. You can see that. Photodiode, the arrows are reversed. That is, it is coming reverse. We call it as a IR diodes or IR receivers. Zener diode, little on the cathode side, you will have bent type of a this thing, the line. So you can make it out from it's a Zener diode. Why the Zener? What is the work of the Zener diode? It works like a regulator, right? Regulation, voltage regulation, right? It is used as a voltage regulation. So detector diodes, just now we have discussed demodulation in radios and all. When RF signal is coming and you want radio frequency to be removed and you want the pure signal, that is called as demodulation. For that purpose, we will use a detector diode for that purpose. Okay, you have tunnel diodes, high frequency diodes, variactor diodes. Again, this is a high frequency diode. Then you have Schottky diodes. Okay, like microwave oven or microwave signals, which are very high frequency signals. There we will use a Schottky diode, right? So these are the different type of diodes you have to remember, and you can just see this. Now, mostly we discuss about the diode, that is the working of, we call it as a rectification. What is rectification? Converting AC into DC. So all power electronics, power related circuits, you will find this diode, that is nothing but rectified diodes. Okay, right. Okay. Now, when we talk about rectification, half-wave rectification will be there. Only single diode is used. Full wave rectification, we will use two types. That is center tap full wave rectification. One is called as, and one is called as bridge rectification. Okay, bridge. In bridge formation, we have 4 diodes, whereas in center tap, we have only 2 diodes. But the transformer will be center tap transformer we will use. All these circuits I will show you in the practical in the coming classes, how to make this. Okay, so half wave, center tap, and bridge rectifier. These are the 3 forms of diode. Rest of the things, how to test the diode, we will just see in the practical session. All right, students, we will see in this video how to test a semiconductor diode. Okay, so you can see I have kept many this diodes over here, and few of the diodes are inside circuit. Okay, LED is also diode. This is Zener diode. For same type, you will get signal diode, detector diode. This is also diode, rectifier diode with a little thicker this thing. That means the ampere rating is more. This is also rectifier diode. So how to test a diode? So first of all, on the multimeter, you have to put the value or the selector switch to diode mode. Take the diode, right? You have 2 probes. Okay, just connect one probe and see what is the value. Nothing is coming. Okay, now what I will do is I will just reverse it. I'll put negative here, positive here and negative over here. I've got some value. Got it? Once again, I will show you. Reverse it, no value. Reverse it, you got value. If this is the case, that means your diode is okay. If both the side you are getting the value, your diode is short. Both the side you are not getting any value. Only value means when you are using an Ohm's range. Okay, you are not getting any value. The diode has open. Okay, right. So this is one diode. This is another diode. Same process. Let it be this diode also, Zener diode also. Right. Okay. So what do you mean by that? It works on a forward bias. Okay, it will not be there. It will not work on a reverse bias. The same thing here. But how you'll find out anode and cathode in this? A marking will be there. Okay, that is cathode. Okay, marking. Here also you have marking, but in black the marking will be white color line, silver line. Okay, so let's check this diode now. This diode I want to check it. How it shows? Nothing. Reverse it. It is showing some value. Okay, so simple. This procedure is same. Put it on this thing. How to check this diode? That is LED. Simple. Same this thing. But here you don't have to worry about the values. You will get the LED will glow. If LED is not glowing, the LED has gone. Okay, the junction has broken inside. But if LED is coming, it is working all right. Okay, you have to understand this because this LED is glowing due to the battery which is inside the multimeter. Now, SMD diodes also you can just check. These are the SMD diodes. How can you check the SMD diodes? I will check one SMD diode. So this is on the PCB itself. I will just try to check. I'll just put it like this, and I will just check. No value. Okay, I will reverse it. Some value of what? Okay, the diode is working. So you can just see these are the SMD diode. This is a little bigger size. This is also diode. This is also diode. This is also diode, and these are also diode. These are all diodes. Okay, so same thing. Here also you have got marking. Here also you will be having one side the marking, but the size is very small. One more diode I wanted to show you on the PCB. Like this is a package. Package diode means it's a bridge rectifier. Okay, you can see here it has 4 points, 1, 2, 3, 4, and it is given also plus and minus. So 4 diodes. You can check the same way what I have checked it here. Same 4 diodes will be there in a pack. So you can just find it out whether the diode is working or not. These are all rectified diode. This one over here. So please remember, mainly the diodes are used for rectification purpose. Of course, it will be used for regulation also. The signal diode will be used for regulation, right? Okay. And the signal diodes are used for converting the signal or detecting the signals. So these are the function of the diodes.